Well, good day to you, my dear friends. Let's solve some LeetCode problems, as usual. But it's very hot today. But still, I hope I'll manage, and I hope my PC will manage. But as usual, let's start with some problems from previous days that we solved live, and now I have a lot better solutions for these problems. For example, this problem from 2 days ago: search in a binary search tree. Let me find my old solution. So, for a couple of days now, I have the same problems. In an hour or so, or a couple of hours after I end the stream, I get struck by this new idea how to solve a problem in a better way, but it always happens later, like in an hour or two, when I upload the video to YouTube, or when I do something completely different. Still, all of a sudden I'm struck with this realization. And this was the case. I was doing, I don't remember what, but all of a sudden I realized that in this problem we have a binary tree. Binary tree. And well, what is our goal here? Let me remind you. Now we have this tree, and we have a value, and we need to traverse this tree to check every node and to return the node with the same value as in our val. And what I did, I checked each and every one of these nodes, but it's a binary tree. And each node, like node with value 4, it has two nodes, left node and right node. And the value of the right node is always bigger than the value of our node. And the value of the left node is always smaller. So we do not want to check both directions. We want just to check if our value is bigger, or lesser than the value of our node. And this idea struck me all of a sudden when I was doing something completely different. And of course I implemented this idea. Let's do something like this. If, let's say, if root value is smaller than value that we are looking for, then we go right. Right, this one. And else we go left. And we don't need all of this. And of course we want to what do we want? We don't want anything. I think that's it. Let's run it. Of course. And we want to check if this root right exists at all. Let's do it like this. if great. So it's a lot shorter solution. But now let's dive deeper and I will demonstrate to you the best approach, the best possible solution, well, as I see it. And of course, I invented it using all these different solutions. And in the process, I think I discovered the shortest one, and I even uploaded the solution myself. But let's not be too hasty. We have this check every time if we have this root right or root left, but we can just add a guard clause, you know. We can return something like this, return nil if no root right, and then we do not need these checks, because if we send root left and it doesn't exist, well, it's not a problem. Let's see. Good. It's all good. Now we have this condition, root value can be less than val or bigger than val, and it can't be equal because we already checked for that. So we can use a shorter form, Let's check if root val is lesser than val, and if it is, we return a root right. Otherwise, we return a root left. And this is going to be an argument in our search BST call, like this. And of course we need a second argument, and it's going to be val. Like in both of these cases, it's just val. And we remove all that, and it's even shorter. And it's working great. Now, notice that we return nil if we do not have root. If the root is nil, right? So we can say that we want to return root if there is no root. And it will be the same thing, because in this situation root is equal to nil. Let's try it. Great. Now we have two checks. Here we check if not root, and here we check if root value equals to val, and in both cases we return root. So we want to return root if there is no root, or root value equals val. Then we don't even need this check. Great, it's beautiful. And of course we can even remove this empty line, but it's like a good practice to leave an empty line after return. So this is a shortest solution with recursion, but there is another way. Of course we can achieve the same result using just while loop. Let's do this. Let's say that our root equals equals, let's call search BST, and again I'm gonna use this ternary operator in the same way. If root val is less than val, then this whole thing. So we are doing this, but only while there is root and our root value doesn't equal value. Something like this. And after that we just return root. Let's see. Oh no, wait a second. We don't want search BST. I told you that we will do it with just while loop. So root will be equal to root right or root left. Wait a second. Depending on this condition. Yes, we don't have to call search BST again. Great. So these two, I believe, are the shortest solutions to this problem. Oh no. Yeah, and I'm not sure which one is better. Oh, we have a extra one here. They seem equally good to me. So this is problem number 700, searching a binary search tree. But also a few days ago, not a few days ago, yesterday, I solved this problem, the latest login in 2020. And I don't know, something stupid happened. Let me find my solution, my crazy solution. This one. Well, this is the most stupid thing in the universe. And I only created this thing because I tried using this max keyword or max command, I do not know how to call it, here, and nothing worked. Maybe it was a typo, so I had to implement this craziness. We do not need this at all, because this max timestamp, it works just here, and we do not need to, I don't know, to join all this craziness. Let's use max timestamp here, and in where clause we leave just this part. And of course we will want to, yes, to group by a user ID. Here is our output. Here what was expected, and it's green. And look, it's so easy on, and of course I invented this second solution like an hour later, yesterday. Why wasn't I able to come up with this solution during a live stream? I have no idea, but it always happens to me again and again and again. So Maybe it's just a learning curve, I don't know. But of course there are some things to, you know, to fix here, to refactor, you may say. First of all, this where we can just use between, of course, instead of and. I think it works like this. Probably another way around. Of course. Let's see. Let's check. Oh yes, it doesn't need all these brackets. Well, still need and, but it's a little bit shorter. But of course it's not the best approach. Now we can use like keyword, and we can use 2020 with percentage sign. So we will find all timestamps that, hello Vladimir, that I lost my thought, that starts with 2020. Let's check. And it's green, but there is even easier way. We can just extract year from timestamp and check if it equals 2020. Yeah. And this is, I believe, the easiest way. Now, let's take a problem from that I solved some time ago, not live. Whoa, we have a new person in our chat. Well, hello. I guess not, but of course send it to me and I'll check it. And we'll see how it goes. But right now, let me show you this problem. If you remember, a few days ago I told you that I do not know anything about promises. Good. Copy it and I'll check it later. Algo newbie. Oh yeah. That's me. I'll check it later and I'll see if it can replace a LeetCode. So this problem, add to promises. A few days ago I told you that I do not know anything about promises, but after that, you know, I found some information on promises, I studied them a little, and I was able to find the simplest, well, not the simplest, you know, the most basic solution, let's call it like that. So we have two promises, and we send these promises into this function. And in this function, we want to return a new promise. that will resolve with the results of these two promises. It sounds a lot harder than it is. What we want to do? We want to, well, return promise 1. Well, here is promise 1. And when it resolves, we get a result 1 from it. And after that, we don't do anything with this result yet. But instead of this, we run promise 2. And we get result 2 from this promise. And here we use them both, result 1 and result 2. And we get the sum and we return everything. And we have this promise in the end. But there is a lot better approach to this, because I found out about promises just 2 days ago, but I didn't know anything about await and async, and we have a async function there. So what can we do instead of this craziness? By the way, it works. Let's check it. So it's always nice to find a solution on your own. Okay. Instead of all this, we can just return await promise 1 plus await promise 2. And that's it. Let's check it. Yes, it's all green. So, what is this await? Await is just a synthetic sugar, as they call it. And it really does the same thing as what I wrote here. Await promise 1, it stops everything that goes after it until it is resolved. The same thing for this await, and then we just, return this, the same promise. And I wasn't sure if we return promise here, because we have a condition that we should return promise, and I wasn't sure if await returns promise, but I checked it in. Let me open console, and let's do something like this. We have promise 1 and promise 2 from our tests. We have this function that returns await promise 1 plus await promise 2, and we console log the result. Let's run it. So we see that this is a promise. And I think this is the best solution to this problem, because, well, they have a async word here for some reason. Probably they want us to use await somewhere. The problem with await and the problem in my original solution is that it takes a long time. First we wait for the first promise to resolve, then we go here and wait for the second promise, and the same thing here as well. We wait for both promises to resolve one after another. And of course, in solutions section, there are many people who are, well, they do not like this result because they want to run promise. How can I explain this to you? We have a third way. And it looks like this: promise all. If I remember correctly. And promise all, it takes as an argument an array of promises. So let's give it an array of promises. Promise 1, promise 2, they are in an array. And then we have to use then keyword. And in our usual promises, we get the result. But in promise all, we get all the results in one array. Let's call it values. You know? Do I buy premium for a year? No. No, I do not have premium. I do not have any money. How can I buy premium? I can't even pay for my GitHub Copilot. So no, I do not have premium, but there are so many problems. Even without premium. I mean, look here. Most of them are available for free, but we can't see solutions for these problems. For example, here solution is closed. I mean, editorial solution. We can examine solutions by other users, but it's not the same thing. So what we are doing here, we have it's such a tricky subject. Here we waited for the first promise to resolve, and then only then we launched the second promise. But in promise all, we start, all these promises one after another. We do not wait for one to end to launch the next promise. I mean, it doesn't mean that they all work in parallel. They still launch one after another, but they do not wait for each other. You see, they do not wait for previous promise to end. They just fire right away. Well, their timer is fired right away. So this promise all will be resolved when the last promise of all these promises will be resolved. So probably in like 60 or something like this. You'll see. So we have this values array, and we want to sum these values. And in Ruby we have this nice method for arrays, just sum, and everything sums up, but not in JavaScript, of course. Here we need to use reduce, and I hate reduce. Okay, and here we have two parameters. Let's say value and accumulator. Let's call it like this. And value is our value, just like 2 or 5, whatever we get from our promises. And accumulator is a current sum. So we want to add our value to the current sum, and it should work nicely. But also we should add 0 here to show that this accumulator should start with 0 and not with 1 or 2 or minus 100 or something else. Let's check. Yes, great. Runtime, we can't really charge runtime here because it doesn't work. It's very buggy. But here is the second approach, and of course it's better because it's faster. We do not wait for first promise to resolve, But the thing is, in our condition here, we do not have, they do not ask us to solve this problem. They even write to us here, at the time the return promises resolves is not judged for this problem. And if it's not judged, then this solution is probably the best. So these promises, they are tricky. It's hard to explain them. But at least I was able to understand them, you know. It's something. Now, let's solve something new. And preferably not too hard, because it's such a hard day, it's such a hot weather. Oh, it's impossible to think, it's impossible to talk, but we have to solve a problem, some problem. What do we have here? Final prices with a special discount in a shop. Oh, sounds like an SQL problem. No, it's not an SQL problem. Let's see, what do we have here? You are given an integer array prices, where prices I is the price of item in a shop. Prices J. Oh my god, such complicated rules. They have this tendency to overcomplicate things, but usually it's with examples it's a lot easier to understand. So we have prices, and for item 0 with the price 8 we will receive discount equivalent to prices 1 equals to 4, because J is because index 1 is bigger than index 0, and 4 is lesser or equal than 8. Jesus, that's crazy. And of course we have all this other 6, 2, 3, they're all good, because the index of 6 is bigger than the index of 8 and 6 itself is smaller than 8, but we are looking for minimum index. So the first one we meet is actually what we need. Yes. Let's think. Okay. And of course, let's add an array of results. Maybe we don't even need a new array for this. So we have this price. We need a while loop here, I believe. Let's call it starting index. And while prices starting index +1, of course. And we will simplify and refactor it later. I'll finish typing and I'll explain everything to you what is going on here. So, what's going on here? We go through prices, the array of prices. So we arrive at the first element, 8. And we want to check all the next elements in prices. And for this, we start from the next one, index +1, so this is a starting index, and we launch a while loop. We check if there is an element at this starting index, and there is in our case. It's element number 4, or not number 4, just 4. And also we set this discount variable equals to nil. And we only continue with our while loop if we do not have a discount. So we arrive at this next element and we check if this element is smaller than our original element, and 4 is smaller than 8, so we set a discount. Discount is a price minus original price minus this next element, and we do not continue anymore because we already found this suitable element with the smallest index. Probably we don't even have to wait, but no, it's all right. Here we want to take our price and we want to I don't like it because there are so many conditions. Of course we can simplify it, I'm sure, but for now let's do it like this. Because if we do not have a discount like this last element 3, we do not have any elements after this one, so we do not have a discount, and we should just return this element itself, the price itself. Let's do prices. Index equals this if condition. And in the end we want to return prices array. I don't know. Maybe it's crazy. It doesn't work. Oh, let's see. Course. Well, of course j is more than I. Will it be the same if we use a brand new array? Let me just check it. I'm curious. Probably be the same. Yeah. Okay, let's see. Why is price? Wait. Come on. It's strange that only this one, broke, not all the other ones. Okay, so we don't need this array. We can do this with just prices. And it will be a lot better. because we managed without creating another array the same size as the previous one. It's a bad thing and we should avoid it if possible. So many problems. Because it's too hot, it's impossible. You don't understand, guys. Yeah, that's good. But let's try to refactor. Okay. Let's go back to description. Let's do it like this. Let's remove all this. Let's remove this check, and let's just break. And we don't need this as well. Yeah. Now. I thought maybe it's possible to solve it without this extra variable. No, we need it. Well, then that's it. Do we need these prices? I don't know what this iterator returns. No, we do not need this. It's even better. So this is it. Yeah. And I swear, in an hour I'm going to invent a much better solution. But it's not going to be live, during a stream. It's a constant problem for me. But for now I'm happy. And it's such a hot weather, so that's it for today, I think. We did a lot. We did like 4 problems. And it was hard for me to explain promises to you. I promise. I will explain promises to you some other time. I prepare. So this is it. Goodbye, guys. It's time to travel. It's time to go. See you tomorrow.